Today we're looking at how to add complex numbers. So to begin, let's just go ahead and talk a little bit about complex numbers first. So a complex number in standard form looks like this, a plus bi, where a and b are real numbers. They're integers, so they can be positive or negative, and they're rational, so they can be fractions. They can even be irrational numbers, like the square root of 7 or something like that. But they are in the real number system, whereas this I stands for the square root of -1. So if you want a complex number in standard form, you have to go ahead and simplify and manipulate it until it looks like this form, where you have a, your real number, plus bi, where you have a real number times the square root of -1. So for example, we have -2 plus 3i. This is in standard form, where -2 is the real part of the complex number and 3i is the imaginary part of the complex number. So any number can be written as a complex number. So for example, the number 3 is actually 3 plus 0i, because 0 times I is just 0, so you still have 3 plus 0, which is still 3. So this is important because if they want you to write in standard form of a complex number, you have to know that 3 can be rewritten as 3 plus 0i. And if you have 4i, if you want to write this in standard form, you can't just write 4i, you have to write the real part and the imaginary part. It just so happens that your real part is just 0, so you have 0 plus 4i. So this is actually in standard form here, 0 plus 4i. All right, so let's practice. Let's write in standard form, which is a plus bi, where a is your real part and b is your imaginary part. So 17.3, that's a real number, so that's your a. So you have 17.3 plus 0i, because there's no imaginary part, so that means that your imaginary part was multiplied by 0. So this is in standard form here. All right, -3i. In standard form, that would be 0 minus 3i. So notice that the negative became your subtraction. All right, here is a one that's a little bit more complicated. You have 5 plus the square root of -12. So remember, you have to write it where you have an I, and I is the square root of -1. So the first thing we want to do is we want to break up the square root of -12. The square root of -12 is the same as saying the square root of -1 times the square root of 12. And then 12 can be broken up if you factor it and you do a factor tree. 12 breaks into 2 squared times 3, which means that this 2 can actually break out of the radical and live on the outside. So now we have 2, the square root of -1 is the I, leaving just 3 on the inside. All right, so let's take a look at this one. This is also not in standard form yet. However, we can make it in standard form. Since we have a numerator divided by one denominator, we can actually break that denominator up and put it over each numerator. So now we have 3 over 2 minus 4 over 2i. And then we can simplify. This 4 over 2 is the same as saying 2. So now we have 3 over 2 minus 2i. Okay, let's do another one. So that 7 can go under each numerator. So we have 6 over 7 minus 5 over 7i. All right, let's do a practice. Go ahead and see if you can do this one yourself. Okay, you should have gotten option number 2. The 3 is going to go under each numerator. So you get 4 over 3 plus 6 over 3i. And 6 over 3 reduces to 2. So that's why option number 2 is the correct choice. All right, so when we're adding and subtracting, The most important thing is to combine like terms. It's almost like when we were dealing with x and solving for x and we had to combine like terms. We're doing the same thing. We have an I, and so anything that has an I in it, as long as it has the I in it, you can combine it with other I's. So an I plus an I is 2I. So let's go ahead and look at this. This one is subtracting. So before you can subtract, you actually have to distribute the subtraction. So you're going to have minus negative 3, which is actually plus 3. And you're going to have minus 10i, which is negative 10i. So if you're combining, you have negative 5 minus negative 3. So negative 5 plus 3, which is negative 2. So that means it's either going to be option 2 or option 3. And then you have negative 2i minus 10i. So negative 2i minus 10i is negative 12i, which means that it's option 3 is the correct answer. Okay, let's try this one. Again, since we're subtracting, we have to distribute this negative. So it's going to become minus 10 and minus negative 7i, which is plus 7i. So you have negative 21 minus 10, that's negative 31, which means that we're either going to have option 1 or option 4. And then we have 5i minus negative 7i, which is the same as saying plus 7i. So 5i plus 7i is 12i, which means that option 1 is the correct choice. All right, last example, we have 4i minus 3 minus 5i. So again, we have to distribute this minus. So it's going to be minus 3 and then minus negative 5i. And minus negative 5i is actually the same as saying plus 5i. So we have 4i minus negative 5i, which means that we have 4 plus 5i, which means that we have 9i. So now we're looking for a 9i, which means that we either have option 2 or option 3. Both of those have a 9i. So let's see. Then we have minus 3. So we have a negative 3, which means that our correct answer is option number 2. All right, go ahead and try some problems on your own.